You're listening to another episode of Open Source CXO, the podcast designed to share insights on how to excel in your business using technology, regardless of the industry. Host Robert Kehoe is a self-taught software developer who has grown to the role of CEO. Renowned for his collaborations with organizations such as Stanford University, Nelnet, and Louis Vuitton, he continually seeks new challenges to conquer in the world of tech. Accompanying him is Don Blackburn, a veteran COO with over 25 years of experience in cultivating diverse relationships and driving innovation in various technical projects. Each week, they'll be sitting down with some of the nation's foremost technology leaders to develop an open source playbook, drawing from their firsthand experiences in the field. Let's talk some tech.
Today, our guest is Arturo Pino. Arturo, welcome.
Thank you.
This is kind of a unique podcast for us, a little bit different. We've done a lot of CTOs, a lot of CIOs, and things like that over the history of our podcast, but I don't believe we've done anybody from the manufacturing industry. I think we're going to take a deeper dive into manufacturing and how tech kind of relates to that and how it adds to manufacturing and so forth. So with that, why don't you tell us a little bit about yourself?
Yeah, so Arturo Pino, I got my engineering degree in mechanical engineering here at UMKC in Kansas City. Originally went to the University of Oklahoma for a year and then ended up graduating in 2014. And I did also do a little bit in computer science at Georgia Tech through their online program. Ultimately, didn't finish that. I kind of prioritized some of the things with work and family and some other endeavors. But for the first 5 years of my career as an engineer, I was doing manufacturing process and product. And in the manufacturing world, you have kind of three different engineering titles or roles. You're either product, process, or quality. And you're working out on the manufacturing floor, standing up operations, working with operators and factory technicians, trying to make sure that you're producing good quality products, and then that the throughput, the yield and all those kinds of things are coming out to ultimately to be profitable, but to also meet the requirements of the customer. So I spent a lot of time on the factory floor. I spent a lot of times with designers on the requirements that they were trying to drive. And the industry I worked in was aerospace, and defense. And so there was quite a bit of a focus on quality and precision, much more than high throughput. So it was a maybe smaller volume, but higher precision, higher quality kind of technologies. But lots of very unique products. And I worked particularly in the polymers area, so manufacturing composites and plastics and rubber and a bunch of different components in aerospace based on those materials.
Was that all IT related? Did you jump into the IT side right away, or it sounds
no,
like you were engineering?
No. This was hardcore, just mechanical engineering, for 5 years. But when I was at UMKC, I was actually the TA for the mechanical engineering program's computer programming introduction course. Okay. And the electric circuits as well. And so I did that for a couple semesters. And so I just always enjoyed writing software. I liked writing code. So when I got to, my first job as an engineer, a lot of the things that I did was just automating simple tasks in Excel, writing macros and VBA, and kind of got pretty sophisticated with that. There was actually one application I wrote all in Excel with user forms and a whole bunch of automations to gather data from our measurement systems. Mm-hmm. We have these large machines called coordinate measuring machines, and they would gather measurement data on parts, to determine if they meet their specifications. Mm-hmm. And so it would generate a CSV file per part, and so you would have hundreds of parts, and so you'd have hundreds of CSVs. And you would end up having to figure out how to parse all this data and put it all together and aggregate it so you could do your analysis. People were spending hours just aggregating data, literally copying and pasting. So I wrote a VBA script that just walked through all of that and parsed it and kind of showed it to some people, and everybody liked it and asked me to put more and more stuff into it. And I was using it for myself as well. And I got really into statistics. So there's a methodology in manufacturing called Six Sigma, which is focused on statistical distributions and evaluations of manufacturing processes. So you can make sure that a process is in control statistically. That's a statistical terminology, process in control, and that you know what your capability is in your process. And so there's sigma meaning standard deviation. So there's a bit there. And so in order to be able to do the analysis that I needed to do on my processes, I needed to aggregate data. And so it was very data focused. But you very quickly, if you wanted to be efficient, had to write some software. I mean, you can get kind of far with just Excel formulas and that, but to really be efficient, I started writing these little applications in VBA. Eventually kind of just pushed the limits of that and got into Matlab, which is what they teach in mechanical engineering school typically is Matlab, proprietary language, licensing model. And it's a great software for what it is, but it has its challenges in that you have to have a license and that you have to set it up with,
Is it expensive? Is that?
It's also very expensive, yeah. And in the universities, you usually get a free student edition. And so you kind of learn in it. And so you come out to the workforce, you end up just using it because that's what you learn.
Exactly.
Especially in mechanical engineering. I think it was really more recently that they started introducing Python in mechanical engineering classes as an alternative to MATLAB, because with libraries like NumPy and Pandas and now some more advanced stuff that's coming out with polars and other kind of data frame based stuff, you can do quite a bit. And then with signal processing for sensors and actuators and that kind of thing, like Python does quite a lot that you don't really need MATLAB anymore. Actually, when I was at my first company, initially I ended up somehow becoming the site administrator for all the MATLAB licenses.
Oh,
Yeah, because
sounds like it falls under your purview, I'm sure.
Well, it turned out that it was assigned to me. I was voluntold to do it by the previous MATLAB lead who left the company, and I guess he was looking at the heaviest users of the MATLAB licenses in the site, and he said that I was the heaviest user, and so he's like, you clearly know the most, and
Of course.
people need to ask questions, and so they're going to go to you. So yeah, I took it over, and one of the things that I was actively trying to do is reduce the number of MATLAB users that we had, because I was trying to push them towards open source, towards Python, because you can just do so much, and it's much more scalable tool.
It's easier to find developers, I would imagine.
Yeah, that
Probably wouldn't say, cheaper developers, but probably a lot more aggressive in terms of salaries and whatnot.
Yeah, well, it's just more accessible for learning. You don't need a license seat. You don't need their IDE. You can just spin up VS Code, or there's a whole bunch of online editors that you can just go into and start learning off of YouTube videos. So when I was teaching people in the engineering area, which chemical engineers, materials engineers, I was basically starting to teach everybody how to use code because it was such a useful tool.
So is the MATLAB? I'm not familiar with MATLAB. Is it not code then? Is it's more?
No, it's code. But
okay.
it's their own language. It's very
Gotcha.
Python-like syntax-wise, although it is base index 1, which is kind of a whole thing. So it doesn't start at 0.
Yeah, that's actually a complete flip of the script for like every other language out there.
I know. It's a whole debate.
That would really
out there.
screw me up.
Yeah, but I did quite a bit of that. I wrote an entire 3D printing software toolpath generation code with an IDE. Sorry, not an IDE, a GUI, a UI for operators in that language, and eventually kind of pushed the limits of that. But this whole time, I was really into software. I was doing all these statistical analyses for the processes that I was in charge of, and I was trying to better produce data and pipelines of data. Ultimately, that process where I was just parsing CSV files became an entire software application that was statistics focused that ended up being used by over 200 engineers in the company on a daily basis. I mean, I actually had, use logs that I wrote into the software so we could see, how effective it was being. And so that was kind of my first experience of the scalability of software and just how useful you could be with it. And so that's kind of what got me into it. I ultimately ended up applying to Georgia Tech to their computer science master's program and completed a semester there. And from that point forward, I was like, I just got to be in software. Now, I'm still an engineer, mechanical engineer, and so I like manufacturing. I like the hardware side. Mm-hmm. So I spent 5 years in that kind of position, being a product or process engineer. And then there was this opportunity in a new department that just got stood up called the Advanced Manufacturing Technology Development Department. And I wanted to be in there because that was research and development for manufacturing. So we were designing new manufacturing systems, techniques, machines, particularly 3D printing applications that I kind of spent another 5 years iterating over. Ended up, writing it over 3 times before I was done. But we built a team as well. I ended up there being the lead engineer of a department that had about 18 engineers, and so I was kind of helping or really leading that organization to not just on the software side and to bring software capability to the department, because we really didn't have any software people. It was just me for like 3 years.
That's what I was going to ask. So it's a large company we're talking about that shall remain nameless, but they didn't have an IT department when you got there, or they did and it was more business?
Well, you have to kind of differentiate between the IT organization, and this is actually something that I'm pretty passionate about even now as a CTO at HIX Corporation, but IT and OT, operational technology. Operational technology typically falls on the factory floor side. And so IT, depending on the types of organizations, doesn't always get involved in manufacturing software technologies. Yeah, they're focused on infrastructure, right? Database management.
The business side, right? The clients, the accounting, the CRMs, right, the HR systems and stuff like that.
Particularly the large enterprise systems. Whereas when we are doing manufacturing, we either are outsourcing a lot of that to a Matlab or a SolidWorks, or these engineering tools, analysis tools that you kind of just buy and install and then use. But the organizations that do build software for the systems in house are tied typically to specific technologies or to specific departments. So, for example, we had a very large test equipment part of the business that only developed testers for the products, like electrical testers, voltage, current, all these different PCB and printed wiring assembly testers. And so they wrote a lot of code and software for those testers. And those were, typically low-level kind of applications. We also had an internal business apps development team, and so they would write, code that would pull data from our existing databases, make dashboards, those kinds of things. But on the side of actually developing manufacturing technologies, like the robotics and the motion systems and the actuators and the stages and all these things, there wasn't a lot of software capability on that side. Specifically in the group that I was in, advanced manufacturing technology development, it was very materials focused and mechanical engineering focused. And we were trying to do 3D printing, and we were trying to use, commercial or open source slicers, but that really wasn't fitting our use case. So we ended up building that ourselves.
The 3D printers, something that I've run across a few times with clients and stuff like that. I had one that gave me a tour. They had a whole lab of 3D printers going 24 hours a day, building different components and stuff like that.
Yeah, and those are typical, maybe commercial, but usually more of a residential kind of 3D printer. We were building, 4 foot by 5 foot by 9 foot tall 3D printers.
And they were specifically building pieces for the manufacturing process, I'm guessing.
No, that was building final products.
Oh.
Yeah.
Is it common for manufacturing companies to have, it almost seems like a lot of your experience come from just like this discovery or the research and development. Yeah. So they've given you this freedom to go out and like build these products or kind of almost do whatever is needed. Is that pretty common in this industry? That sounds like, because in a lot of industries, they don't want to do that at all.
Oh, yeah, I agree.
And, that's usually why they would contract us. But in any case, like that's like pulling teeth. I just find it so surprising that you have that autonomy. I don't know. I thought that in itself is awesome.
Well, I was very fortunate to work in that group. That was a group that was a little bit unique. I would say that it's not very common.
Okay.
But the challenges that we were trying to solve, for national security, this was a defense contracting business, just required some unique technologies that just didn't exist in commercial industry.
Government money, though, that's what it was, huh?
Yeah. Funded for, our defense.
Fair enough.
But this actually brings me to where I am today, which is, I'm CTO of HIX Corporation, and HIX is an incredible company. They're 65-year-old manufacturer in Pittsburgh, Kansas, and they've been there throughout, the decades, doing a lot of manufacturing that's kind of on the opposite side, rather than like aerospace, they're working on commercial products. So they make industrial screen printing equipment. They make industrial food equipment and industrial ovens and dryers. So still industrial equipment, but for the commercial side. And it's a much smaller company, under 100 people, and they don't have big budget to invest in heavy R&D and in-house software development and in-house hardware control. Now they do a lot of internal controls. To your point, we had a very large organization that allowed us to put in the investment into R&D for these new technologies. At HIX Corporation, it's a very different story. I kind of came in, and the goal is to modernize the company to be ultimately a smart factory.
Yeah.
The other role that I kind of adopted at my previous company was I led what we called the Big Data Consortium, which was an organization that allowed us to build in-house large data infrastructure so that we could manage all of the data that we were generating on the production floor and in our IT systems. And that kind of gave me some insight into how the IT organization works, how cybersecurity works at a large enterprise, and then how you actually get data from the production floor into a large infrastructure like that. So we had our own on-premise big data cluster. We had all of the internal resources that we needed to execute on that. Many people on different teams, IT, cyber, engineering, business. And so when COVID happened, there was a lot of disruption in the supply chain on the manufacturing side. And I think everybody kind of had a wake-up call, realizing that there was a lot of inefficiencies and gaps in manufacturing in the United States, particularly with supply chain vendors downstream. So there's some very interesting statistics on the demographics of the manufacturing industry in the United States and how it's evolved over the last 30 years. Particularly, the manufacturing industry has lagged behind in technology quite significantly. And this became apparent when the supply chain disruptions that happened during COVID required a large amount of technology to pivot and to adjust. I mean, you just see, even just like remote working in and of itself was a major shift. And so a lot of manufacturing companies don't have the capability to implement those types of technologies because a lot of their processes are still paper-based processes. They still have clipboards that they do.
I was actually going to ask that because my perception of that industry, and I think we had a few clients in this industry, actually, but I think we still do, but it always seems to be legacy systems, a little bit historic, a little old, a little dated because everybody's a little afraid of change, but that's what it seemed like.
We've had two just in the last year and a half that were manufacturing their local that were very, I don't want to say archaic, but very behind the times with technology.
I think they're just now trying to
catch up a little bit on the business, but that was still on the business side, not necessarily on the shop floor.
But is my assumption fair? Is it pretty common in this industry to have sort of outdated, historic kind of systems? And
absolutely, that really is my mission. Part of my mission with what we're doing at HIX Corporation is to show manufacturers, not just at HIX, but we're trying to be open about what we're doing at HIX, and this is something we hope to do a lot more in 2025. And part of why I wanted to be here today is to talk about some of the things that we're doing, because it's very difficult in the manufacturing industry to overcome the technology challenges that we have. A lot of the efficiencies are driven. There's a lot of things that drive it, but one of the primary enablers is technology. And the reality of where we're at in the United States right now is that it's very difficult to integrate enterprise scale systems into small manufacturing businesses. When you look at
why is that though? Is it because they're expensive? Is it because they're too cumbersome? Like, why is it?
That's a very good question. There's really two things that drive it: cost, which is a big one, and know-how.
Always is.
Cost and know-how, and you could say that that's true about everything, but particularly in this space. Going back to the resources that I had available to me at my previous company, I had an IT organization, I had a cyber organization, I had an engineering organization, and I had a business organization. There's not even an IT guy at most of these manufacturing companies, right? If they're running on a legacy system, there's maybe a domain controller server in a closet somewhere that is running the whole business, and there's a SQL database on it that runs some software from the 90s or the early 2000s that the whole business runs on.
Yeah.
And that's just the way it's been. And to integrate something different requires a lot of investment, cost-wise, but also know-how.
Yeah.
And so this is where the integrators really kind of come into the market. There's kind of like this catch-22 situation where in order to be able to integrate like let's say an ERP, enterprise resource planning software, which allows, basically it's typically in manufacturing environments, you have an ERP, MES, manufacturing execution system, and an enterprise resource planning system, at least in large manufacturers. And these two systems, either these are two systems or it's one system that kind of does both functionalities, but they're very high cost in licensing, and they're very difficult and complex to integrate.
Yeah.
And so really the only way to integrate these is through an integrator. And a lot of these, so like NetSuite from Oracle, Dynamics 365 from Microsoft, Epicor, SAP. I mean, there's these very large systems that are designed for enterprise class, manufacturing operations. But in order to get there, you have to already have a lot of resources to be able to integrate those.
Yeah.
And even the integrators that have the expertise to put them in place are very expensive as well. And so, it's very difficult as a small manufacturer of 20 people to, invest hundreds of thousands of dollars in licensing
It's a huge
annually,
shift, it sounds like.
and hundreds of thousands of dollars in integration fees,
Yeah.
Annually or at least as a front-up cost. So it's a massive barrier. Going back to the resources that I had available, we were able to pivot during COVID because we had a lot of resources and we were integrating a lot of that technology internally. The small manufacturers didn't have that technology in place in the first place, and it made it harder to integrate during COVID. And so they've had just this constant challenge of how do you integrate technology and how do you become more efficient. At smaller companies, so because a lot of the integrators cater towards large enterprises, you don't really have integrators focused at small to medium-sized businesses. And I'm talking about everything from ERP, MES, but also like large-scale inventory management systems. In large facilities, you see very advanced barcode-based systems where all your inventory is tracked through checking in and checking out of locations, where your bins and your storage locations are. And then in your manufacturing operations, when you have a work order, you're processing raw material, you're moving it from one location to another location, and the software is managing all of that. In a small business, you don't have all of that infrastructure in place. And so what ends up happening is rather than going towards integrators to build one massive ERP system, you end up with going to a lot of SaaS solutions for individual components of it. I call it death by 1,000 SaaS guys.
Yeah,
right.
I totally get that, man.
Yeah, so you get one SaaS solution that can do inventory management, and then you go to another SaaS solution to do your CRM. Then you do another SaaS solution to get your help desk set up so that customers can submit support.
So many
tickets.
different products.
Right.
Yeah, then you do SaaS for project management, right? How do you manage projects? You do SaaS for work orders, so your manufacturing floor can manage. A lot of these don't even have those. And you do SaaS for chat apps. You do SaaS for collaboration tools. Mm-hmm. So many different SaaS applications that not only add to the complexity, because many of these SaaS systems don't necessarily talk to each other natively. Mm-hmm. They may have open APIs and all that.
You could use like Zapier or something.
Right, yeah. You'll have even...
It's frustrating, trust me.
Right.
We've had to talk a few of our clients like, okay, we need to dial that back a little.
Right, so you end up with a lot of different systems, which in and of themselves, those systems may do a very good job, but when you're trying to run a company and you have 20 people in the business and one guy knows how to use one of the tools, the cross-training capability is very difficult. Yeah. So there's just a lot of friction to get momentum. Mm-hmm. And you may be able to improve operations in one area. Maybe you get really good at inventory management, but if you're trying to process a sales order and there's not a good way to take a sales order for your products and then put it into inventory as a demand,
right?
there's somebody that manually has to do that. And it's typically ends up being exporting Excel sheets and importing Excel sheets, or literally just typing, keying in values. So there's all kinds of this stuff happening. The companies that are trying to get ahead, trying to leverage some of these SaaS tools, are now finding all these additional challenges. And so it's like, what's the point?
Right.
It worked better when we were just doing everything manually on paper, right? And so there's just a lot of friction to get past it. So what I would like to do at HIX, and what we are doing, is trying to, in the tech world, and this, you guys are very familiar with this, you have this concept of a tech stack, right? And when you have a tech stack, you've kind of identified, or the industry has collaboratively identified, a set of tools that work together seamlessly, right? You may have a certain database, a certain programming language, a certain UI framework, a certain way of doing things, and they've even got acronyms for them because they're industry recognized. And so you look at a suite of tools, you put them together, there's documentation on how to integrate them, and then you can build really good products with those, because you don't have to build everything from the ground up. You don't have to build all the integrations. You can outsource authentication to Clerk or whatever. You can outsource database management. And then there's a lot of cloud tools, but you have a tech stack. There's not really, at least as far as I've seen, much of a tech stack culture in manufacturing. Every company is just trying to figure out for themselves, and they're picking tools that either are cold called or marketed, or somebody sees something and they try to bring them in, they buy a license, they try to figure it out. And so you have this iterative process of trying to figure out how to run these systems. And so what we're trying to figure out at HIX is, can we build a tech stack for manufacturing? And we're not saying it's the only solution, but it's a solution of these known technologies where we can consolidate as much functionality as possible in the most modern way, leveraging open source as much as possible. Because this really tries to attack those two primary issues. Open source, trying to attack the cost problem, but a tech stack that's fully, kind of pre-configured and has documentation so that it's easy. The know-how problem is not so significant. And then by sharing what we're doing with other manufacturers, we hope to kind of spread that about, because we really feel that we want to help bring manufacturing back to the U.S. in a lot of different ways, and however we can do it. And we want to help lift manufacturers up, because manufacturing has had a rough ride the last 30 years. And there's a lot that kind of rolls into that historically, culturally, and now there's a big appetite to bring it back.
Yep, there's a political environment that's really supporting that. So
yeah, not only that, but even just socially, if you look at what happened during COVID, when the supply chain disruptions, people thought it was ridiculous that there was no toilet paper.
Yeah,
Right.
Because we don't make toilet paper.
Right.
Right. So if the supply chain gets depleted and there's no offshore, shipping and all these processes, then we just lose the supply chain. We don't make stuff here anymore.
Yeah.
And so there's even a lot of social. It used to be that we really pushed manufacturing away. We said, well, services are the way that the U.S. is going to grow in its economy in the future. But ultimately, no large civilization has ever succeeded if they lose their industrial capability, their industrial base.
Sure.
And